So, welcome to Flat Shading Low Poly Landscapes. What we're going to do in this video is quite a lot actually, and you don't need to understand all of the detail. We will revisit some of these things later. This would be 5 or 6 videos if we go into too much detail. But the end result will be I'll show you how to make a landscape with a lot lower geometric detail like this, where you can actually come in and paint on the landscape in very simple flat colors like your grass here or your dirt, and where we create a very special type of material which uses this collection of nodes, which I'll briefly explain but not go into a huge amount of detail about how it works, to make the terrain flat shade, which is what's giving this effect here where each of these faces are looking like flat faces. Okay, that's the magic sauce, is what we do in here with these nodes. So let's dive in and show you how to create the option for a low poly terrain if that's your preference. So before you make the decision whether you want to pursue the high poly route or the low poly route, I just want to talk about the implications. One of the things is that Unreal's tools are actually really powerful and will help you make a very photoreal looking external landscape with only a few more hours work than we've done so far. The disadvantage of that is that you've just set the bar for the rest of your game. Now suddenly if a player sees the scenery is that realistic, they're probably going to expect everything else they see to be realistic. There are ways around this. Think of games like The Vanishing of Ethan Carter, for example, or Everyone's Gone to the Rapture. Those type of games are absolutely beautiful environments, but there's very little interactivity. You see, if you want a photoreal environment with photoreal characters like GTA 5 type thing, you're talking about spending 1,000 man-years of effort to produce it. And a lot of that goes into the art, sound, storytelling, etc., etc. So be careful how high you set the bar. Some people may choose to set a low poly bar for all of their assets, and then you can really focus on the core gameplay. So let's see how we would make this low poly. What we're going to do is just go to the world outliner and delete the landscape. Now if you choose, by the way, to stick with high poly, as I say, just don't do this, just watch this through out of interest, and in the challenge you can use the time, instead of making a low poly landscape, you can use that time to tweak your existing landscape. But I'm going to go ahead and nuke my landscape bravely, and I'm going to make a new one. Now this new one, the difference is going to be that the X and the Y scale are going to be 1,000 centimeters or 10 meters. So these quads are 10-meter quads now. That's what makes it low poly. Now 500 loads of 10 meters is a bit too big. This is a 5 by 5 kilometer terrain right now. So I'm going to drop the number of quads and the number of components till we get to 106 by 106. So that's 1.06 kilometers on either side. Same sort of scale as before, with much less quad density, much lower density of information that we can put in terms of the shape of the terrain. So that's it. There's our new terrain layout. Now, let's go start in just a small region, and I'll show you how to do the low poly stuff. And then if you're going down this route, I'll give you plenty of time in the challenge. Same stuff. We model, we pull up. In fact, I'm going to do it from a slightly lower viewpoint. Now, it's not actually super apparent how kind of low poly this is right now, because this preview mesh that we have here is actually what we call smooth shaded right now, which means that the lighting is treating this surface as if it's smooth. What we're going to have to do is try and force the system to start shading this landscape as if everything is flat. And that's a little bit trickier than we may hope, but I'll show you how to do it right now. So here is a piece of landscape. We can imagine putting mountains around the rest, but let's show you how to get to the shading that we want. What we do is we make ourselves a new material. I'm just going to call it flatland. Okay, so I've got a material called flatland. Remember, with a landscape material, the first thing you want to do is scroll down to usage and say used with landscape, as we did before. Fantastic. Now this is where the voodoo starts coming in. How on earth are we going to make this multicolored? Well, firstly, we're going to play the same trick as we did before with the base colors. In fact, you could have duplicated your landscape. That's another way of doing it. Let's do that, actually. Let me just, rather than making flat land like this, let's duplicate landscape and then call it flat land. Okay, there's an alternative for you. If you go into that, of course, it'll already have these two colors. Okay, and it's already set up as a landscape texture. So let's try using this one, this flat land texture on this new landscape. So there's the landscape, into details, choose flat land. Now we need to go ahead and paint, of course. So popping over to there. Now, of course, your paint, you won't be able to see what's going on with this painting until your shaders have finished compiling. So let's just give those a moment to finish compiling. And we're going to need to make ourselves new layer information. You see it's saying there's no layer information assigned. So let's go ahead and make new layer information layers. Now, sometimes it can get stuck in a dialog here, so we may need to just select elsewhere. There we go. So grass layer info flat is what I'm going to call this one. And this is the map of where the grass is, and then dirt layer info flat. Cool. Now we have the layers, we're able to start painting the grass in. Here it goes. So there's the grass on the lowlands here in front of me. Fine. And then the dirt, and we could worry about snow a bit later. Now, if this happens to you, it all just goes wrong like this. This is just because the shaders need to recompile. So bear with it for a second, and it will come back in a second. Okay, here we go. Now, you want the tool strength to be very high so that you don't end up with a mix of two different things. And you can see that, okay, sure, it's low poly, but it really doesn't look low poly. This is not what we mean by low poly. And the reason is the way the shader is shading this stuff smoothly. So how are we going to make it shade non-smoothly? Now that we've got a landscape like this, let me show you. I'm going to go back, if I've got it open, no. I'm going to go back to my content, and then back to the root, flatland. What we're going to need to do is something a bit clever with the normals. Normals are little lines that effectively stick out the surface of the vertices. They stick out of each of the vertices on the landscape, and they tell the shader how light should interact with that surface. What we need to do is we need to make all of the normals for a given flat face point in the same direction. So if we were to, instead of being in lit mode here, if we were to go, say, in wireframe mode, just going to suppress the skybox for a moment, the sky sphere for a moment. There you go. These are the quads, you can see them. What's happening is that little normals are sticking out of all these vertices at an angle that's kind of the average of all the faces around it. Little hairs are effectively sticking out. And then what the shader's doing is, if I've got a normal sticking out of this vertex up into the air and then another one sticking out down here, the shader is interpolating all the way along the line so that it assumes that you didn't actually want this thing to be as rigid as it is, that you want it to appear smooth. So it interpolates in between, and we get this overly smooth result. We're going to have to force all normals that are on the same face to point in the same direction, so that this entire triangle, for example, that I'm highlighting now, has exactly the same angle to the light, rather than having little hairs that stick out in a very organic way. Imagine that the mesh here is like the skin of an animal, and that their normals are hairs sticking on the skin, and those normals tell the light how to interact with it. You can find out a lot more about normals by just searching, for example, on Google. And here, there's a picture of normals there from Autodesk. These are face normals. We're actually using vertex normals inside Unreal, which is more like this sphere here. You see at each vertex there's a little hair sticking out. What we're wanting is that for each pixel wants to be treated as if every normal points in the same direction. Let me show you. This is quite advanced, so if you just want to use this technology rather than fully understand it for now, that's absolutely fine. So what we're going to do is go and find ourself. From the coordinates drop down, there's a node called world position. Okay, and what that's going to tell us is it's going to give us a map of the world position from our viewpoint. Now, it doesn't actually matter whether it's the absolute world position or the camera relative world position, but it gives a vector to the surface at every point. That's the point, from where we're standing. Let me carry on, then explain in context how this works, all right? Now, this is where it gets really weird. We're going to use a couple of features that we can pull off the shader called DDX and DDY. And these are partial differentials in x and y, which is quite mathematical. But what we're saying here by taking a differential in x and y is we're saying when we look at this landscape, as we're doing now, let's put it into wireframe. We want to say, find me places where the change of slope or where the slope in x and y, doesn't really matter whether x and y is the world space x and y or screen space, but in 2 dimensions, the slope is not changing, basically. We only want to change the shading at an edge when the slope of the face changes. So we're finding the slope of the face, or the slope of the thing we're looking at, in 2 dimensions here with this dx and dy. Then we're going to do something called a maths cross product between the two. And what that does is it makes us a little vector, effectively makes us a face normal. It makes a bunch of lines stick out of the face at 90 degrees, one for each pixel. And we pump that into the normal. Now that is not intuitive. It's a sort of solution you'll find on the web, but no one will explain exactly how it works. We're going to have to do this in a spiral way. I could sit and teach you about cross products and partial differentials, and we'll be here for another 10 hours before you've got all the requisite knowledge. So the point of this set of nodes here that I've just made is to calculate, is to force all of the pixels to be rendered the same until you get to a change of face. That's the idea. Let's see it in practice. We're overriding the normal vectors for the pixels of our terrain. So you click save. Once it's finished saving, you can come out of it, but then you're going to have to wait until you can see the effect. So here is the preview again. You see now that's doing exactly what we want. The blending's a little bit weird in places, but that is what we're after. Okay, and then given that, you can then just come back to the landscape tools and we can just take the dirt, paint the dirt where we want it, and we can paint the grass where we want it. And we can raise and lower the terrain and do all the things that we've been doing before. Sculpt, circle brush, nice large brush, you see? And we're actually generating a low poly terrain. Now we get some blending between the different cells, so the green and the grey blend into each other, but that's absolutely fine. That's pretty manageable. So back to paint, for example, come here, put some dirt up here, and you see that's working. So we have a low poly terrain setup. So what I'm going to leave on the screen is this node setup for you. This, we will revisit this type of stuff as and when necessary, but just bear in mind that we are detecting flatness, basically, and forcing faces to shade flat, because unfortunately, with a landscape type material, there's no simple button we can click to say render this flat, or certainly nothing that I know of. You could add in a third color here. You would just add in another vector parameter, which would put in, say, snow, and then you'd have 3 colors. So that's what I want you to do. I want you to choose your final landscape style. Decide which route you want to pursue. If it's high poly, then use this time to tweak the existing terrain you've got. I'm going to pursue high poly, I think, through the rest of the course because that's been the consensus. I want to show you in the upcoming iteration of terrain, I want to show you how to use height maps and import those sort of things. So ultimately, I'm showing you both techniques. But if you decide low poly, then create your initial landscape like I just did. Remember to leave a flat area in the middle of that landscape and then share the result with the rest of us so we can see either on Facebook or in the questions and answers what you've done, because we'd be really interested to see your low poly result. I'm not going to flesh my low poly terrain out anymore, as I say, because on the next iteration I'm going to show you how to import a height map as a third alternative to terrain generation.